I'm Stephen Wolfram, and I've spent my life kind of alternating between doing basic science and building technology. And hopefully a bunch of you use some of the technology we've built, things like Wolfram Alpha, Wolfram Language, Mathematica, and so on. And some of you might be aware of written a bunch of books, like one called The New Kind of Science, that's about a new kind of science that has had many consequences. And I do a fair amount of live streaming every week about Q&As about science and technology, things like that, that perhaps people are aware of. If not, you might find fun. So that's a very, very brief version. What I do for a living, my day job is I run a tech company that makes software like Wolfram Alpha and so on. And my hobby, I suppose, is primarily doing basic science. We've had a lot of success recently, last few years, in trying to figure out the fundamental theory of physics, how our whole universe is put together. And I didn't think that was something that's going to be possible in my lifetime, but we made a huge amount of progress, which is really exciting to me, at least. And I suppose another hobby I have is things related to education, and do a bunch of things around that, including live streams that I do. And we also do an annual summer program for high school students, as well as ones for grown-ups and one for middle school kids and so on also. So those are a few of the things I try to do.
And
go ahead.
Sorry, I understand you have a podcast as well, right?
Well, I do typically 2 live streams per week. They alternate in topic. One of them is called Q&A about science and technology for kids and others. And another one is about future of science and technology. Another one is about business, innovation, and managing life. Another one is about history of science and technology. And they kind of alternate in twice a week, one or other of those topics. I see we have various people on camera here, and maybe somebody has a question or something.
Popping on. So is it cool if we jump into some student questions for you?
By all means.
One of the kids emailed me earlier today, and they want to know, what were your main sources of inspiration and the biggest challenges you faced early on in your career?
Well, remember, I'm an old guy, so I grew up at a different time from today's time. And when I was a kid, I grew up in England. Space was a big thing, and this is late 1960s. Space was kind of the big, exciting thing going on at the time. Kind of funny that for a long time, space wasn't that exciting. It's now exciting again. But I got interested in physics, actually, when I was about 10 years old or so, and started to want to learn as much as I could about physics, and discovered this amazing thing. You could just go find books and read about stuff and learn about it. And so I did that. And I suppose one of the things that was a good meta-discovery of mine was that there were all kinds of questions that came up. I was curious, what's the answer to this? What's the answer to that? And sometimes those were questions that were kind of like the exercises in the book, but sometimes those were questions that were nothing to do with the exercises in the book. But I decided I'm going to go try and figure out the answers to these questions. And that led me on to lots of kinds of projects that were, as I now realize, kind of original research projects. At the time, they were just like, here's a question I want to answer. Let me go and try and figure out how to answer this question. And I suppose I actually one such question that I got really interested in when I was 12 years old, actually, was about this thing in physics called the second law of thermodynamics. It's the kind of law that tells one that things tend to get more random. If you have something that's sort of systematic motion, you're moving something, it will tend to dissipate that sort of systematic motion into heat. That's kind of random motion of molecules. And the question is, why does that happen? What are the general principles behind that? That's been sort of a mysterious thing for like 150 years. And back 50 years ago, I was really curious about it and tried to figure it out and didn't manage to figure it out. I finally think I figured it out 50 years later. And I just wrote a book about the second law of thermodynamics last year, which is kind of, I think, finally a resolution to this question. So it took a while from when I sort of formulated the question as a kid to when I actually got to answer the question. But when I was a kid, being interested in physics and things, one of the things that was always kind of frustrating about thinking about physics was, oh, you had to do all these mathematical calculations and you had to do all these things that involved, doing algebra and this and that and the other. And I was like, I know what calculation I want to do, but it involves this giant piece of algebra that's going to take me several days to do. But it seems very mechanical. So, can't I find a way to automate that? And so I got interested in using computers. At the time, a computer it happened that the school I was at had a computer, which was very unusual at the time. It's a big thing, size of a large desk, and it was programmed with paper tape. And it had, in today's world, you might have a computer with hundreds of gigabytes of memory. So the computer that I used had, basically 24 kilobytes of memory. So that's probably 1/1,000,000th of the memory that a typical computer has today. But I got started using that when I was 12, 13 years old, and discovered that, yes, all these things that I found very mechanical and frustrating to do myself, I could get a computer to do them. And so in a sense, things like Wolfram Alpha are a long-term consequence of the fact that when I was a kid, I wasn't very keen on doing all that algebra and so on by hand. And I said, let's delegate it to a computer. And so I tried to do that for myself, and it's ended up being pretty useful to millions of other people in the world in subsequent years. But so one thing was kind of discovering this kind of, in a sense, secret weapon for me of using computers to calculate things that I was sort of really surprised other people didn't do that, because it wasn't that hard, I thought, to do. But it became sort of the way that I could do physics and so on, sort of a superpower for doing those kinds of things. Now, in today's world, I've tried to build tools to sort of give people that sort of computational superpower to do things in science, technology, other areas. And that's kind of what I've spent my life, in a sense, building, is those tools to give people kind of the superpower to use computation to figure things out. But for me, early on in my life, I suppose I don't know, I felt like I was just, I'm one of these people who just, like, I decide what I want to do and then I try and figure out how to get to do it. And most of the time it's, one ends up doing big projects. Some of my projects have lasted, 10 years, 20 years, and so on. There's always a certain amount of sort of personal push that you have to do a project that lasts 10 years or more. But I would say that I wouldn't have said that in my own internal view, I've just been continuing to do things, and it's not like there've been huge barriers to what I've done, except for the fact that the things I've done are quite big and sometimes take a decade or more. I would say that quite early in my life, I got my PhD when I was 20 years old, actually, which was very good because it meant that I'd sort of gotten through the education system quickly, and I wasn't going to be sort of frustrated waiting for things to happen there. But then I ended up sort of backing into building my first company when I was 21 years old, 22 years old, maybe. And that was some sort of interesting, because I had this kind of self-image of being kind of an academic, techie type kid, and I kind of was backed into starting my first company because I developed a bunch of technology and was trying to figure out what to do with it, so to speak. And at first I was kind of like, I don't really know how to do this, things like running a company. But then I realized, at least for me, that sort of the things you have to figure out about running a company are in some sense common sense. They are common sense so long as you kind of keep actually using the analytical skills that you might have from, let's say, doing science or something like this, and apply them to these kinds of questions about business and running companies and so on. So that's I don't think I'm not. I wouldn't have said that my life has consisted of overcoming great hurdles, except that every day I do projects that are pretty hard and that haven't been done before. And one of the things that I suppose even after all these years, I'm always sort of the projects I'm doing are never easy. Like there's a project I'm working on right now about AI and its relationship to science and so on, and the project is hard. And I was yesterday working on it, and it's like there's some questions where it's like, yeah, I should be able to figure this out, but it's not like it's easy. I immediately know what to do. Even after everything I know, all the tools I built and so on, it's still a hard project. And I suppose that's partly a choice that I make in life, that I continue to work on hard projects. It's very satisfying because you do a series of hard projects. And by the way, every time you do a hard project and it works, you get a little bit more confident that the next time you're going to do a hard project, you will actually be able to get it to work.
That's
Let's see, other, please. What are you guys interested in? What kinds of, do we have a lot of STEM interested kids, business, technology,
pretty much
science?
all of these kids are involved in STEM on some level. I have a question from Christopher in Spain, I believe. Christopher, go ahead and ask your question, friend.
Hello. My question is, what is your biggest project?
Ever in my life or right now?
I think he's saying ever in your life.
Yes, in
Well,
your
my
life.
biggest project is building our Wolfram language technology stack, which is something that, I started the thing which is now Wolfram language in 1986. So that's ancient times by your standards. And I'm still working on it every day. In fact, I just before this, I was doing a live stream, doing a review of some software design for sort of things we're building right now in Wolfram language. So that's probably my biggest single project, which has been going well in its current form for 37 years, and sort of a precursor of it for about nearly 10 years before that. I've also, the kind of another very big project of mine is kind of direction in science that has to do with studying simple programs and seeing what they do. It's kind of a very fundamental area of science. In mathematics, you say, I've got these kinds of mathematical constructs, whether it's, addition or derivatives or whatever else, and I see what consequences those have. But there's a much more general kind of science that has to do with studying sort of arbitrary kinds of rules and figuring out what they do. And I think the thing that has that kind of science, I said I wrote this book called A New Kind of Science. That's a big book. Look at this. I think I even have a copy of it. Let's see if everything just falls down if I take this copy out. There we go. This is a big book that took me 10 and a half years to write back in the 1990s. And you can find this online, by the way. There's a nice online version of it that's really available out there. That project kind of has had many. I started that project at the beginning of the 1980s, and that project has gone in several stages as I've discovered more and different things. This new results and ideas about fundamental theory of physics are sort of a consequence of that. I think maybe you were also asking a different question, which is, what are my biggest projects right now? And I can answer that as well. I mean, in addition to my kind of long-term projects like building out Wolfram language, I also just recently started something that I suppose is of potential interest, which is I've been trying to write a book and a course about computational thinking and about kind of an introduction to computational thinking. And there will be, starting probably by next week, there'll be little pieces of this book that start appearing online, and people can tell me how terrible they think the pieces are before I write all the rest of it. But the sort of the concept there is this: if you are talking about how do you sort of work out things about the world, well, sort of human language is one way to kind of express oneself about things in the world. Another way is something like logic. Logic is sort of a formalization of things in the world. Another way is mathematics and sort of mathematical representations of things in the world. Computation is kind of another way, a more general way, actually, to sort of represent things in the world. And it's kind of, how do you think about things in terms of computation? And by the way, when you think about things in terms of computation, a computer can help you figure stuff out. And so that's very powerful. So I've been trying to write this thing, which again, in the category of this should be an easy project, because I've been thinking about computational thinking for what, 45 years or something now. You would think I could just start on page 1 and just write it. Turns out when you take something that you kind of has been sort of a thing you've taken for granted for years, it actually isn't so easy to be able to express what the sort of fundamental ideas are. And I've been, well, it's been complicated. So that's a big project that I'm doing right now. A project I'm doing specifically right now, which hopefully will get finished fairly soon, is to answer the question of it's sort of the topic is, you know, can AI solve science? To what extent can AI kind of help us understand more about science? There are ways that it can do small pieces of that, but is there sort of a big thing that's going to happen as a result of AI in science? And the answer is there are significant limits that have to do with a phenomenon I call computational irreducibility. It's basically the idea that you might think if you know the rules by which a system operates, you can immediately figure out everything about what the system will do. Well, in principle, you can by just following those rules, seeing step by step what happens. The question is, can you kind of jump ahead and say, well, the system would have had to do 1 billion steps of following these rules, but I can just say what the answer is going to be. That's a thing which people have tended to assume you can do, but you can't always do that. There's this phenomenon, as I say, that I call computational irreducibility, which is the inability to jump ahead like that. And that limits both our ability to do science and AI's ability to do science. But that's a specific project that I'm working on right now. The other, oh gosh, there are a lot of things. This fundamental theory of physics that we've kind of developed is really quite a wonderful thing. I mean, it's really the last time there was really big progress in figuring out how physics works was basically the early part of the 20th century. And there's a set of things that got figured out at that time about how gravity works, how quantum mechanics works, and so on. We kind of have the next step in that. And it's very fertile. There's just a lot of things to figure out, but it's complicated. And we're trying to figure out things where you can actually, you know, turn a telescope and look at something and see, yes, we can see some new feature of the universe. One of the most obvious things in our models is that space is discrete. So people had argued for millennia about whether something like water was a continuous fluid or whether it was made of discrete things, molecules or whatever. That finally got established at the beginning of the 20th century, that yes, things like water, materials are made of discrete atomic things. But space kind of got left out. People thought maybe space was discrete, but nobody could figure out how to make that work from a kind of theoretical point of view. So people still at this time believed that space is kind of a continuous thing. We just put something any place you want in space. Turns out that isn't true, so far as we can tell. Instead, space is kind of made of discrete elements, just like something like water is made of discrete atoms. The discrete elements that make up space are vastly smaller than things like atoms. But as the question is, can we detect something? It was difficult to find out that atoms exist. Can we detect things that reveal the discreteness of space? And that's one big project that I'm working on, is trying to figure out how to go from these models that we have about how things work in physics to something that you can actually observe. So, and there are a bunch of other projects. There's another one I might mention, which is a kind of a project that, well, people tried to do this project like about 300 years ago and sort of gave up. And I think it's time to try and do it again. And the project is this. It's kind of like with logic, we have a way to kind of make certain statements about things, not just in ordinary language, but in some kind of symbolic form. The question is, can we express things that we would usually just talk about in everyday language? Can we express that in some sort of precise computational symbolic form? Trying to figure out how to do that. It turns out it helps a lot to have things like LLMs, like ChatGPT and so on. They are both an indication that this must be possible and a practical tool that helps one to get to the point where one can do this. So that's another big project I'm doing. Other
you
questions?
are a busy guy. So Delhi, she is in Europe. Delhi, go ahead and unmute. You had a pretty good question. Go ahead.
Hello. My
Hi.
question is, how do you feel now having accomplished all of these activities in your life?
How do I feel? Well, it's nice to have gotten these things done. One thing that has been interesting for me is that there are a lot of projects that I started a long time ago where I thought this is the direction one should be going in. And mostly other people didn't think that was the direction one should be going in, but I went and did it anyway. And it turned out that they were very good directions. I mean, the things that built in technology and a lot of things I've done in science, sort of what people believe has slowly evolved closer to the things that I've believed for a long time. And it's meant that a lot of what I've done is still kind of, I call them artifacts from the future. They're things where, when you guys are my age, people will say, yeah, that was the obvious thing. And, it was, but it took another 50 years to actually happen. And so it's sort of interesting because there are a lot of things I've been able to do, which are sort of have gone out many years ahead of perhaps the time that one is in now. And that means that it's sort of, the story isn't over. It's not like I can say, okay, I've done this. Now I've done everything I can do on that. There's nothing more to do. We're still sort of, it's still something that's growing and climbing. But it's very nice to have managed to get done the things I've gotten done, partly building tools, both sort of intellectual tools for thinking about things and practical technological tools for doing things. Having this tower of kind of tools is super useful for being able to see further and so on. And it's nice. I like that. And it also helps, as I say, that I've done things that have worked out okay. And so that means, like, I was just this morning talking to folks at our company about a project that we're doing where people say, oh, this project is impossible. This is the very common thing that you hear. And it's like, look, guys, it's not impossible. It can be done. I know it can be done. And I'm fully confident that it can be done because I've seen so many other projects that at first sort of seemed impossible, but I kind of have an intuition about what is doable. And it seems like I've usually been right about that. And that's satisfying. But, I have to say, when I was a kid, I sort of wanted to be a physicist when I was grown up. And I had the good fortune by the time I was like 20 years old of sort of being a physicist. But there were things that I was keen on, like I thought, I'll write these papers, academic papers, and won't it be cool that I write one of these papers, it gets published, and then I can go to any university library anywhere in the world and I could find my paper. Well, at the time, that was a really cool thing. These days with the web and so on, it's a little bit easier to take what you do and kind of have it spread around the world. But it's very, there are things like that I think are sort of satisfying. And also for me, it's like, I like understanding stuff. I like understanding new things, new questions. And that's always very satisfying. And the more you understand, the better platform you have for understanding more things. And I think it's a thing, often people say, well, you should learn kind of the principles of doing things, and that's true, but you should also learn a bunch of facts about things. Because when I figure stuff out, I figure things out in, I would say, probably 95% of what I'm able to figure out, I can figure out just because I know a bunch of facts. And I can put together, a fact from this place, a fact from that place. Oh, by the way, these things match up, and that allows me to figure out a new thing here.
That is absolutely fascinating. And guys, if you want to learn more, check out StephenWolfram.com. We'll have all of the websites that are correlated with him in the video and the recording that'll be available later this week. So Dr. Wolfram, before we let you go, I always ask this of our guests. Is there any advice that you can give to these kids as they go off into the world and kind of figure out what they would like to do?
Well, the first thing is figure out what you actually like to do. And it's not necessarily a thing they teach in school, so to speak. Another thing, different people have very different kinds of profiles for what they want. I mean, some people like doing little projects that last a couple of days and it's really intense. Some people say, I want to do this big project, it's going to last a year, 2 years, whatever it is. It's a different kind of thing. I don't think there's a single sort of size for everybody, and different people, have different things that really work for them. I would say that if I were to sort of have a few comments, I mean, one is learn tools. Tools let you sort of get much further. And I will say in a slightly self-serving way that the tools that I've spent my life building, I think are good tools to learn. They kind of the tools we built with Wolfram Language and Mathematica and so on get used by a pretty broad spectrum of kind of the world's leading research and development folk and so on. And the cool thing is that you can actually use these tools. Kids can learn to use these tools, and many kids do. And like I wrote a book called Elementary Introduction to Wolfram Language, which you'll find on the web, which is a good place to start and kind of introduces kind of this computational language that we built. And with that computational language, you can go out and figure out stuff that's never been figured out before. There's the fact that there are these very powerful tools that now exist that, you kids can have perfectly good access to and so on, means that there are things that just nobody's been able to figure out this or that thing because the tools haven't existed before. And it's really remarkable the extent to which it's possible. You have questions that you want to answer, whether it's about some kind of data that exists in the world. Can you analyze it and figure out, why is it this way rather than that way? Something about math where you ask, why, what happens with this kind of mathematical function or numbers or whatever else. These are things where it's, learn the tools, then you can, you have something that is very powerful and where there's just a huge amount to be figured out and which hasn't been figured out yet. I'll say another thing about kind of the direction in which one goes and around these tools, among other things, is if you look at different fields of study, from archaeology to zoology, so to speak, there is sort of, you can apply computational thinking to all of these fields. But that's a new thing, that's possible. Computational thinking is a new kind of way of approaching the world. So for every one of these fields, there's going to be a computational X. And that computational X will be a powerful kind of way of approaching that field. Get into computational X, or whatever X you're interested in, and it will be, you'll be kind of out ahead of the pack in that area. And that's a thing where, that is in our century, so to speak, now, sort of computational X is the thing that will sort of take over every field. This kind of approach of computational thinking. We know computers as practical tools have been very powerful in the world, but that's just the beginning of what's possible by thinking about things in computational terms. So I suppose those are a couple of sort of suggestions and comments. I would say that a thing, it is, different people have such different ways of approaching things. And when you look at, my particular trajectory is well optimized for sort of my particular personality and so on. I'm a person who likes to figure out everything for themselves. I don't like to just be sort of told, do this, do this, do this. There's nothing, it isn't necessarily an advantage to figure out everything for yourself. It's just the way that I happen to do things. And sometimes, like I was just realizing of something we've been doing at the company now, that sort of a thing that everybody sort of says, you should do this. And I've kind of ignored that for 30 years. Now I've kind of realized for myself, yes, this is the thing we should be doing, and it works out well. But by golly, I could have been doing it 30 years ago if I'd listened to what other people said, you should be doing this. So, it varies with my particular approach is figure out everything for myself. That means I get to do a lot of things that have never been done before. It also means sometimes I'm 30 years late in doing things that everybody else knew what to do with. So, I think these, different and people, some people kind of, it's really good to be in some setting in school where you're kind of with a bunch of other kids who are sort of doing similar things to what you're doing. When I was a kid, I was often, was off learning about physics. No other kids I knew were very interested in that. And, I never talked to teachers about it and so on. I wrote a bunch of stuff that never showed up. I finally put it on the web like 30 years after I wrote it. So that was a different kind of thing. But in any case, it's worth. I always like to believe that for every person, there's a really great thing that they can be doing in the world. It may not be obvious what it is. It may be a thing where you say, I really like doing this thing, but by golly, the world doesn't care about that thing. But usually there's a way to figure out how to find the niche where you can make that be a thing that that you can do in the world. I mean, you can be lucky or unlucky. You know, if you want to be a sort of explorer who's exploring, you know, trying to find the source of the Nile or something, well, we're 150 years too late for that. You know, I've been lucky in that a thing that I really find very satisfying, which is kind of working out the sort of intellectual consequences of this idea of computation. You know, I've lived at a time when that's right what can first be done, so to speak. It's a time when that can first be done, and so that's really a cool thing. You know, if I had wanted to be an explorer of the outer planets in our solar system, well, I lived at the wrong time in history. So it's you know, there's a little bit of kind of luck in that regard, but I think that it is usually the case once you figured out sort of what it is you really like to do, that you know, then you have the challenge of, can you sort of solve the puzzle of how that fits into the world as the world actually is. And I'll make one last pitch here that I about our summer programs, and actually we have a whole collection of programs for pre-college students. The one that I'm most involved in is our what we had called our summer camp, but it really isn't a camp in the traditional sense, but it's a physical thing in the Boston area, and we do it every year, and we have scholarships and such like, and it's a thing where you can look it up on the web. It's one of the things that I think is important about it is that every kid who comes gets to do their own kind of original project, and I suppose one of my main roles in that program is come up with original projects for 70 students or something every year. It's I used to be, a long time ago, I used to be a professor at universities, and I haven't done that for a long, long time, but this is my moment, my 2-week period of sort of extreme professoring, so to speak, in figuring out what those projects should be, and getting to know lots of very interesting kids who've gone on to do lots of very interesting things, and that's always I always enjoy it, and I recommend it to people who are up for that kind of thing. And it seems like we've run out our time here.
Yeah, but thank you so much for taking the time to speak with us, and we can't thank you enough. And it was absolutely fascinating, guys. If you want to learn more, and we have it in the chat about the summer program, annual summer program, and we'll also send it out with this recording as well, so you guys can learn more. Check out StephenWolfram.com, Wolfram.com, WolframAlpha.com. And before we let you go, Stephen, before I end the meeting for all, traditionally, I allow everyone to unmute. And can we all thank Dr. Stephen Wolfram for talking?
Thank you.
Thank you. Have a nice day.
Check out his podcast.
Have a nice day.
Thank you.
Thank you.
Bye.
Thank you.